Doing 5-5 part 2. Today we're just going to do the graphing of inequalities, and it's a system of them. We did it a couple of chapters ago. If you remember, like graphing the inequalities, that's where you graph like the solid line or the dashed line, and you have to shade in that situation. So let's start with the most challenging one, this first green scenario right here. What kind of line will this be if it only has one letter in it and that one letter is an X? Horizontal, vertical, or oblique? Let me try that again. Horizontal, vertical, or oblique? Vertical. So we're going to draw a vertical line. Do you remember, since this doesn't have a little equal to bar, it's going to be what? Solid or dashed? Dashed. And it's got to go through -1. So take your straight edge and draw that vertical line dashed through -1. But here's the weird thing, is that's not just the one thing that we're supposed to graph. We're supposed to graph a couple of things on this one. So we are supposed to shade this guy. Where do you think the greater than means we would shade? Like, you can't go above or below a vertical lines. You can go to the left or to the right. Where are these X values greater than -1? To the right of it or to the left of it? To the right. But what's going to end up happening, especially later when we graph 3 of these at the same time, sometimes you have 4 of them at the same time, sometimes you have 5, you're going to make a mess, right? You start doing all this shading, you're just going to make a mess. So instead of shading all this, don't do it. It's going to make a mess. I like to put helper shade. So helper shade is just like this right here. Please do that. Just showing yourself, yo, bro, I'm supposed to shade to the right of that line. But instead of wasting all that space and wasting my pencil, it's like, all right, this first green line scenario, it's got to be X greater than -1, so I shade to the right. Let's graph this second line in this case. Could you tell me horizontal, vertical, or oblique? Horizontal. Solid or dashed? Solid. And it's got to go through -3, so I'll make that solid guy be in a horizontal line going through -3. And this guy would need to get shaded as well. And here's what we're doing today. We're solving the system of inequalities. The system's answer is where, like, the green shade and the red shade would overlap each other in that case. So honestly, the red shade, according to this, where do you think that is, since that's a less than, above or below? Less than means what? Below. The red shade is, honestly, don't do it yet, is right here. Are you with me that the red shade is all there? But you know what? I think we're smart enough to realize this area right here didn't matter one bit. Do you know why that area didn't matter? Because the green shade wasn't there in that case. Isn't the final answer going to be right here? You can shade this in nice and good, because that's where the red shade and the green shade like totally would overlap each other. That is to the right of that guy and below the other dude. So any ordered pair in that final shaded region would satisfy the system. So let's list an ordered pair that satisfies the system. I'll do a few, then you make up your own, right? What do you think about this ordered pair? Would that satisfy the system, yes or no? That's at 6, -5, right? I'll do one more. Would this ordered pair satisfy the system? What do you think, yes or no? That happens to be at 1, -7. You can come up with a different one. Right? Homework will ask you to, like, maybe check some boxes, like, does this satisfy or not satisfy? So let's list an ordered pair that does not satisfy the system. What do you think about this guy right here? He is to the right of that green line. Would that purple dot right there satisfy the system? The answer is he in the final shade? What do you think, yes or no? Nope. So that doesn't work. So I'll call that 4, 5. I'll just draw a few more. I'm not going to write them all down. What do you think about this one? Does that one satisfy the system? Nope. This one? Now for the super duper terrific ones, what do you feel about this one right here? Does that one satisfy the system? It's on that green line. Does that green line count or not count? Does not count because it's dashed, right? So it doesn't satisfy the system. What do you feel about this guy right here? Would that satisfy the system? It's on that red line. Does that red line count or not count? It counts, right? So, cool. Let's try again. What kind of line will this guy be? Horizontal, vertical, or oblique? Oblique. Is it in slope-intercept form? Like, is y all by itself on one side of the symbol? Yep. Cool. What's the y-intercept? 3. Let's start there. Bada boom. And then the slope is 1, right? So don't we rise 1, run 1, rise 1, run 1. We'll do 4 points, rise 1, run 1, rise 1, run 1, rise 1, run 1. I don't need to do a bunch because I'm not really looking for where these lines intersect. I'm just trying to graph the lines and do some shading. So when I plot my 4 points, tell me real quick what kind of line, what kind of oblique line, solid or dashed? Dashed. Boom. And then you got to check to see where you would shade at. That is a greater than symbol. So what do you think? Above that line or below that line? Above. But a lot of times we'd struggle with that. So if you put your pencil like on the y-intercept, just like sit it there, and then go above that, that's where it's going to be shaded. And this is our first guy, so I'm just going to put helper shade. So I don't make a big mess. Then I'll graph this second dude right here, asking myself, horizontal, vertical, or oblique. What should that guy be? Horizontal, solid or dashed? Solid. And it's got to go through -1 on the y-axis. So there's -1. So I'll make a horizontal guy. And then this y is all by itself here. That symbol is a less than, so doesn't that mean go below that guy? So I'm looking in this little triangular region. I'm going to use a different color. I'm going to use blue, right? Wouldn't this be like which satisfies both? It is above that green line and below that red line in that scenario. So I will let you and a neighbor find an ordered pair that satisfies that system, and then I will call on somebody. It was suggested that -8, -2 satisfies the system, and we have graphed it, and it does. Right? Now find one that does not satisfy the system. Something that's not in that shade. So one that we suggested was 9, 2, and that is way out yonder, so that doesn't work. Cool. All right. Oh, no! Look at these. What's this going to be? Horizontal, vertical, or oblique? Oblique is y all by itself on one side of the equal sign. Boo! So let's get y all by itself. I need to move the x's over. How do you move this positive 1x over to the other side again? Subtract 1x. I'm going to kind of bring him down here, so I'll have the y there. Oh, whoa, here's a good question. Does that symbol switch when I subtract x? When should the symbol switch? If we multiply or divide by a negative. Awesome, right? So the symbol does not switch. I'm going to put the -x first and then the -1 after that. Cool? And then what I suggest is once you get y by itself, graph that guy, right? Like deal with him, and then we'll go with the other guy later. So let's go graphing him. He's got a y-intercept of -1 and a slope of -1 as well. So boom, 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 boom. Decide if he is solid or dashed, and then make that line. And then put you some helper shade. My trick works when y is all by himself on one side of the equal sign, so we're reading this dude, right? That is a less than, so put your pencil on the y-intercept and go below that dude and give you some helper shade. So there's your first boy. Second boy, same scenario. I've got to get y by itself, but the cool thing is, did you see how I didn't do this work right underneath that? I'm going to do the work for this second dude underneath him. So I just need to subtract my x over, and then I'll graph it. He's got a y-intercept of shui and a slope of -1. Ooh, interesting. What kind of line? Solid or dashed? Solid. And sorry if I'm moving too fast because I have this all pre-prepared. Apologize for that. But where would I shade on this? Above the red line or below the red line? What do you think? Above it. So cool. And here's what I'm looking for. Where the red shade and the green shade overlap. Where do the red shade and the green shade overlap? Well, they don't on this grid, right? But they might somewhere down the line. If these lines end up intersecting somewhere down the line, what do you think? Will these lines ever intersect? You should know that they don't. How do you know that they don't intersect? Because they have the same slope. They are parallel to each other. Are you with me on that? So this one, you'd have to write off to the side, no solutions. Do you think that's always going to happen when you have parallel lines, that you'll have no solutions? It is when we solve a regular system. Like this is a system of inequalities. When you do equations, parallel lines will never intersect. But what if this symbol was a less than or equal to, and that symbol was a greater than or equal to? Wouldn't that mean I'd have to shade like above this green line and below that red line? Would the black shade and the blue shade overlap each other in that case? It would happen, right? So just because you had parallel lines doesn't mean it's going to be no solutions. It's about where the shade is on this. So list an ordered pair that satisfies the system. There are none. There is nothing because there are no solutions. List an ordered pair that does not satisfy the solution. Pick something, right? You know, any ordered pair is not going to satisfy it because no ordered pairs satisfy it. How do you feel about that? Feel okay? Cool. Why don't you pause the video and give this one a try on your own. Decide if they're horizontal, vertical, or oblique. If they're oblique, get y all by itself. So on this first guy, I need to get y by itself, so I added x to the other side. 4 is a y-intercept. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. That's going to be a dashed line. So what's left is to do some helper shade on this guy. You can't quite do that on homework. I don't think. I could be wrong. It's a new program. I think you got to graph both lines first and then like click into the final region where you think the shade's supposed to be, and it'll shade it in there. So you got to select the dash line tool, plot 2 points, and then maybe you click up here to shade. I'll bet you do. And then you click through your second line in that case. And then when you make a dash line and you want to go greater than this, so what you'll do is you'll actually click your mouse in this zone right here, and it will put the final shade to be like that in that case. Does that kind of make sense? You got to click one shade and then click the other shade in the zone that you wanted it to be in, I believe. I could be wrong. List an ordered pair that satisfies the system. So we suggested that 2, 8 satisfies the system. He totally does. He's right there. And 8, 2 does not. And then check this guy out. The 3 for 1 special. So one at a time, man. Let's talk. Well, how about this guy right here? Horizontal, vertical, or oblique? Oblique. I'm loving that y is already all by itself. Thank you so much. Let's graph that guy. So he's got a y-intercept of -1 and a slope of 1. Just watch your lines, especially on the computer. You got to select those before you plot, you know. So this is going to be a solid line. Uh-oh. Looks like I graphed it wrong here. So we'll just start over. On my slideshow, I had it prepared wrong. This is a solid line, correct? But I accidentally had the y-intercept at 1 instead of -1s. Where is this guy supposed to be shaded? Above or below? Above. Little bit of helper shade. All right, little bit of helper shade. Because now we got 3 things to graph. It gets kind of messy if you don't do a helper. Next dude right here, we were not the best at it back in the day. What kind of line is it when it's only got x? Horizontal or vertical? Vertical. Vertical. So we will draw a vertical solid line through -5 on the x-axis. And then what I do with my helper shade is I don't want to put it in the area I know it's not going to be in. Like putting helper shade right here makes no sense because that is not above the green line in that. You know what I'm saying? So like I'm going to avoid that if possible. It's greater than -5, so it should be to the right of the red line. But again, I didn't want to put it down here so I don't make a super mess. Are you with me on that? So cool. And then there's one more dude. Y less than 2. That is a horizontal line, correct? So bada boom. Got to go through 2. And where should we shade in relation to that dude? Above him or below him? Below. And can you see this triangular region shows up right here? It's got to be below this blue line, above this like green line, and to the right of that. So we're just shading in there. That's called the feasible region. So all of those, where the final shade is called the feasible region. That's a weird phrase. So I'll let you and a neighbor work together. Check the box if that satisfies. It's got to be in the orange zone. If it's not in the orange zone, you don't check the box. So 0, 0 is right here. That's a winner, right? 4, negative 1, loser. Negative 1, positive 2. Ooh, negative 1, positive 2. Winner or loser, what do you think on negative 1, positive 2? This dot right here, what do you think? Why doesn't it work? Because that line is dashed or dotted, right? So that does not work. Cool. And then 1, 1. Where's 1, 1 at? Right here. 1, 1 is a winner. Are we cool with that? And then negative 5, a positive 1. Ooh, winner or loser? That's a winner because that line counts. It is solid, right? So it is included. And then 3, 7, 3, 7. That's a loser, baby. How do you feel about those? Cool. Awesome. Is that it? I think that's it, right? Oh, one more. Write the inequalities. How many lines are graphed? Yeah, it's tough to see on black and white. You know, I'll give you that. It's tough to see. Do you see I colored them in? I got a red one and a green one. There's 2. So it doesn't really matter which order we go. Let's start with the green one. How's that sound? What kind of line is my green one? Horizontal, vertical, or oblique? Horizontal. Only have a Y. I would like to do it in green so it matches up. And then you got to look to see where this guy is shaded in relation to that green line. Is it shaded above it or below it? Below. So that would be what symbol? Less than. Should I put an equal to bar underneath that guy? No, because he's dashed. And then I just got to realize where he's at. Where would it go through on the y-axis at what value? 1. Are we okay with that? Didn't have any x's with it because it's horizontal. Shouldn't the red one have both x and y with it? Right? So I will start with a y because I want to do it in slope-intercept form. And then I got to decide what symbol to use based off shade, right? So where is it shaded in relation to that red line? Above it or below it? Above. So that would be a greater than. Should I put an equal to bar? Yes. Then there's just one more thing. Well, I guess 2 more things that I need. I'd like to know the slope, right? So that's kind of hard, especially on the computer, to sit there and count rise over run, but that's what I'm going to do. I'm going to count, like if I call this point A and I call this point B, do you see those landed on grid marks, right? You know, like that's what you're looking for, is ones that landed on grid marks, so you can count rise over run. What would the slope of that guy be? Can't be x. I know what you're trying to say, but it's got to be a number. What's the slope of that? 1, which we don't put, and then he's got an x next to it, right? But what was I going to say? I would like it if I should have previewed it ahead of time. Like that red line, if I look at it, is it got to have a positive slope or a negative slope? Isn't it going up from left to right? So cool. And then what's the y-intercept of that bad boy? 1. Are we okay with that? That's how you write that system of inequalities. Just one dude at a time. Cool. Let us know if you have questions.